Hello, everybody. Good morning, all of you. Okay, we'll see today's quote. Don't worry if you are not where you want to be yet. Great things take time. Okay, nothing happens suddenly. Everything takes time. And the more greater things you want, the more time it takes. So if it is taking time means actually you are going to achieve greater things. Okay, so there is nothing to worry about that. And today is the birthday of Heinrich Henkel. He is a German aircraft engineer who built the first rocket-powered aircraft. He was chief designer of the Albatross Aircraft Company in Berlin before World War I. He founded his company making the first seaplanes and later bombers and then fighters, which achieved fame in World War II. He built the first jet plane and the first rocket-powered aircraft. You can see so many achievements from this person. And after Adolf Hitler came to power, his designs formed a vital part of the growing strength. And but he was a critic of Hitler's regime, and in 1942, the government took control of his factories because he's criticizing Hitler. All his factories are taken. At the end of the war, Henkel was arrested by Allies, but evidence of anti-Hitler activities led his acquittal. So because they found that he is against Hitler, later he is released. Okay, this is about this. You can see so many great achievements. He is first in many things. Okay, so last class we have started partial differential equations, and also we started discussing about system of partial differential equations. If I have system of equations, how to classify them. Okay. So just if we remember, we have classified the PDEs based on highest order derivative. So we say first order, second order, third order like that. And then based on degree of highest order derivative. And then we have classified whether linear, quasi-linear, or non-linear. And also we have classified like elliptic, parabolic, and hyperbolic. And also we have discussed like equilibrium or jury problems, eigenvalue problems, and matching problems. Like that. And then we have taken a general second order equation. So we have taken a general one, a phi xx plus b phi xy plus c phi yy plus etc. Like that. If you and another classification we have seen that homogeneous and non-homogeneous. Okay, so this we have seen that if b square minus 4ac is less than 0, this is elliptic and equal to 0, parabolic, and greater than 0, hyperbolic. right? And we have seen various equations, example equations. So like we have also seen that if m is less than 1, that is elliptic, equal to 1, that is parabolic, and greater than 1, that is hyperbolic. And also we have seen in general time coordinate is one-way coordinate. Okay, so unsteady equations are parabolic. And so if you see, so time derivative or unsteady term acts like a parabolic, has a parabolic nature. And if you have diffusion, like the viscous term, this is elliptic in nature because it doesn't have any particular direction for propagation. It uniformly it propagates in all the way. And but if you take convection term, it can be elliptic or hyperbolic because convection only depends on the velocity, the Mach number and all. So it can be based on it is subsonic or supersonic. So these are some general statements. And also we have seen various things like if I take 2D incompressible irrotational, right? So we have governing equations like del square phi equal to 0, del square psi equal to 0, like that. And also if I take steady 2D heat conduction, so I'm going to get some del square T equal to 0, like that, of such things. These are Laplace's equations. And if I have, actually, even if I have some heat generation, so it may have Laplace's equation or Poisson's equation. These types of equations are elliptic in nature. And we have seen that if you take like unsteady 1D heat conduction or unsteady 1D viscous flow, so like this we will get like Tt is equal to alpha Tx. Dou T by dou T is equal to alpha dou square T by dou x square, or dou U by dou T is equal to mu Uxx. So such things, these are parabolic in nature. And so if you see first order wave equation like ut plus Aex equal to 0, or second order wave equation like utt is equal to a square uxx, like this. These are hyperbolic equations. So sometimes by seeing the equation, because if it is a complex equation, it may not be easier to classify mathematically. Sometimes physical understanding will give you an understanding that whether it is elliptic nature, parabolic nature, or hyperbolic nature. Why I want that is, based on that, I understand how the information propagates, and based on that, I have to decide what type of finite difference form I have to or finite difference scheme I have to adapt. Okay, so such things are needed. So now if I see simultaneous first order PDEs, So if I have like this, so we have seen that there are some methods like if Q is the solution vector, if I can write written in vector form like AQX plus BQY is equal to something like that. If I can write it, then I define a matrix like ADX plus BDY. So if I take like that and if I equate determinant of t equal to 0, it gives equation of characteristic. So again, if okay, now how we classify is if all are real, we take it as hyperbolic set of equations. If all are real but less than number of equations, then they are parabolic. All are real, but because some may be equal, so because of that, number of characteristics will be less. And if all are imaginary, then it is elliptic. And if some are real and some are imaginary, it can happen like that. So this is elliptic by hyperbolic. As I told, sometimes based on the Mach number, it may become this or that like that. So we will say elliptic by hyperbolic like that. Okay, so this is one way of classifying it. There is another way. The second way is if you can write that as again and multiplying by A inverse, I get QX plus A inverse B QY is equal to C. If I write this as a matrix M like this, and eigenvalues of this decides the behavior of equations. Again, if all eigenvalues are real, same thing, same logic, hyperbolic. If all are real but less than number of equations, that is parabolic. If all eigenvalues are imaginary, then it is elliptic. Like this we classify. Okay, so once we understand how to classify them, we will see some examples so that you will have more clarity. Is everything clear till now?
Yes, sir.
Because sometimes connection will be lost. I will not be knowing. I will be speaking and all. And after some time, one fellow will say, sir, no, nothing audible or visible like that. Okay, that's why sometimes I ask. Okay, shall we see some examples?
Yes, sir.
So we will see, we know that 2D, okay, I'll say steady 2D, incompressible, irrotational flow is governed by del square phi equal to 0 or del square psi equal to 0. And how we got this equation from the incompressible condition and irrotational condition. So incompressible means
Densities.
del dot V equal to 0 means dou U by dou X I will write like this. You try to understand. I know I don't write dou u by dou x, dou v by dou y. Ux is dou u by dou x, vy is dou u by dou v by dou y. Okay, another thing, today there will be minor at 6 o'clock. And there, sometimes because I wanted to type like this, but in Notepad or in your LMS, the suffix and subscript and superscript will not take. So if I have like this, it is dou u by dou x. It may be written side by side ux. It is not coming subscript. Is it clear? So if it is
Okay.
like this is actually dou square u by dou x square. Like that you have to understand. Okay, so incompressible condition will give you dou u by dou x plus dou v by dou y equal to 0. And this irrotational condition will give you del cross v equal to 0. And in 2D, vx minus uy equal to 0. The vorticity in z, about z axis. Okay, these are the two equations. So I don't know about this second order things. So, but these are governed by these two first order equations. Okay, so this I have to classify. And what are the variables u and v? So the Q matrix is equal to u and v. Okay, so now if I write this as aqx plus bqy is equal to cr0. C means right hand side matrix 0, 0. So now can you tell me what is A matrix? So A matrix contains the coefficients of x derivatives of u and v. Okay, so B matrix contains the coefficients of y derivatives of u and v. Okay, that you have to remember. If I want A matrix, so see the first equation. In the first equation, the coefficients of ux and vx I have to write. Can you tell me now?
1 1
1.
1
There is no vx there.
0.
0. Now second equation. Coefficients of ux and vx.
0 1
1.
1. So this is A matrix. Similarly, B matrix, if I take coefficients of uy and vy in each equation I have to take. Now can you tell me?
0 and 1.
0 and 1.
And minus 1 and 0.
Minus 1 and 0. Okay, so this is the way I get. Now how to classify? Once I get A matrix and B matrix, I get the T matrix. T matrix is A dx plus B dy. Right? So this is equal to, now can you tell me what is that I get? This into dx, this into dy. For each element I have to write.
dx 0 0
dx
dy.
Dx, and the second element is 0 into dx plus 1 into dy. So
dy
here
minus dx
minus
dx
dx or dy.
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 Minus
dy.
dy. And this is
dx.
dx. Okay. So what is the determinant?
d square x plus d square y.
Dx whole square plus dy whole square equal to 0. I have to get dy by dx. So dy by dx whole square plus 1 equal to 0. So what is dy by dx now?
I imagine
Plus or minus?
Imaginary.
I
Plus or minus I. So what are the equations? From this,
Elliptic equation.
elliptic equations, because they both are imaginary elliptic. We already know, because del square phi, del square psi, they are Laplace's equations which are elliptic. I know that. So it is a verification. So if I, instead of giving like a second order equation, if I am given two first order equations, I can do like this and get it. Okay, so I will do the second method. Second method is write this in like qx plus a inverse b qy is equal to c, right? So this I want, and a is 1001 and b is 0, 1, minus 1, 0. Okay, so what is A inverse? This is because identity matrix. A inverse also same thing, right?
Yes, sir.
So A inverse is A. A inverse is this, and B is 0, 1, minus 1, 0. So I have to get M is equal to A inverse B. So I into B means B only, right?
Yes, sir.
So this itself is M matrix. And so what are the eigenvalues? Eigenvalues how to get? Mod M minus determinant M minus lambda I equal to 0. Okay, so what will I get here? So minus lambda 1, minus 1, minus lambda. Am I right? You know how to get the eigenvalues, right?
Yes, sir.
Yeah, so this becomes equal to lambda square
Plus 1 equal to 0.
equal to 0. So lambda equal to,
Plus or minus I.
so this also shows that this is elliptic in nature. Okay, so this is the way we can do it. Okay, we will see some other example. Maybe we take 3 equations. Okay, so I will take maybe. Okay. Yeah, this we have done. So we will see this problem. 2D incompressible irrotational flow in non-dimensional form. Okay, it is not irrotational. Okay, 2D incompressible inviscid flow in non-dimensional form. Okay, this is the way I take. So one is this is continuity, and momentum equation in x direction we will get, because I'll take steady. Okay, so ut will not be there. You will have u dou u by dou x plus v dou u by dou y. So is equal to, actually I will get minus 1 by rho dou b by dou x. But if I make it non-dimensional, I define like non-dimensional p is equal to p by rho u square. Okay, and so that star is eliminated. So it will be like become like minus dou p by dou x. That 1 by rho gets absorbed by non-dimensional p. Is that clear? Actually, non-dimensionalizing I am not doing. Maybe sometime if you are interested, I will do it one day. But okay, for the time being, you just accept this. Because here u square terms will be there. Usually we define like u star is equal to u by u infinity, v star is equal to v by v infinity, and p star is equal to p by rho u infinity square, like that. So this u infinity square, if I divide, it will become p star. This will become u star x plus v star u star y minus p star x, like that. Okay, anyhow, this is the way I got the equation. If I take y momentum equation, what is that I will get? U dou v by dou x plus v dou v by dou y is equal to minus dou p by dou y. Okay, these are the 3 equations I will get. So I will take that px and py to the left side. So I will get ux plus by equal to 0, ux plus buy plus px equal to 0, and uvx plus vby plus py equal to 0, like this. Okay, this also. Now what is the solution matrix? What are the unknowns? Dependent variables. Q is
ux, uy,
No, what are the primitive variables or dependent variables?
UV.
U, V, P.
p.
3 unknowns and 3 equations I got. So this also, if I write as AQX plus BQY equal to 0, so I can get A matrix. So A matrix, I have to get the coefficients of Ux, Vx and Px from each equation. Am I clear?
Yes, sir.
So can you tell me the matrix?
U,
U V 1
What is the coefficient of Ux?
U sir.
Sir.
1, right? Then there is
0,
no Vx, there is no Px, right? From the second equation, coefficient of
U.
U
0, 1.
0, 1. Px is there, right? So in the third equation, there is no Ux.
0, V,
0 2
0, u, 0.
and 0.
So if I take B matrix, the coefficients of Uy, Vy and Py,
0 1
0, 1, 0.
0, 1, 0.
B,
B, Uy, right? And there is no Vy, there is no
0,
Py.
0.
In the third equation,
0, V, 1.
0, V. Okay, this is the way I get. So now, actually, A inverse B is difficult now. For 2 by 2 matrix, inverse is easy to find out. But otherwise, it is always better to take T matrix only. Okay, so T matrix will be ADX plus BDY. Now, can you tell me?
dx, dy, 0.
Dx, dy, 0.
udx,
UDX plus VDY.
vdy,
Yeah.
0, dy.
D,
X, sorry, dx.
dx
yeah.
0,
0
udx, vdy,
UDX plus VDY,
dy.
dy. Okay. So this is the way I get. Now I have to get the determinant of this. Okay. So what will I get?
dy into
So suppose if I take based on the first row, so dx into, right? Dx into determinant of these 4 elements. So this will become minus dx into udx plus vdy. Am I right? Am I clear about it?
yes, sir, yes, sir.
Yes, sir.
So I will take this minus dy into, so what will I get? Dy into udx plus vdy is equal to 0. Am I right?
Yes, sir.
Yeah. So if I simplify, what will I get? Udx plus vdy if I take common. From the first term, what will I get? Minus dx whole square, right?
dx whole square
In the second one, minus dy.
minus dy whole square.
Like this I will get is equal to 0. So I will get two things, udx plus vdy equal to 0. This is one. And dx whole square plus dy whole square equal to 0. So what is the first equation will give you dy by dx equal to
Minus
minus
v by u, sir.
u by v.
Yes, sir. U by
u by v. And the second one, dy by dx is equal to
1. So plus or minus 1.
plus or minus I.
Sure.
Now you can see that I have mixed real and imaginary. So that's why this we call it as elliptic by hyperbolic. Like this we write. Right? Because I have the convection terms here. Because of that, based on the velocity, right? Sometimes it may be elliptic, sometimes it may be hyperbolic based on whether it is subsonic or supersonic. Am I clear?
Yes, sir.
Yeah. In the same way, we will say some other example. Yeah, this one. It is 1D inviscid compressible flow. Okay, so compressible flow, rho will be there here. Okay, so here if I take these equations, this is a continuity equation, dou rho by dou t, del dot rho v, right? So r v dot del rho, so u dou rho by dou x plus rho dou u by dou x. This is 1D only. That is dou of rho u by dou x, it is split like non-conservation form. Okay, so and the x momentum equation, I have dou u by dou t plus u dou u by dou x because this is unsteady term. This is the convective term. And on the right side, I will have minus 1 by rho dou p by dou x. And this is energy equation. It is not v momentum. It is 1D. Okay. It is taken to be 1D. So energy equation, that is enthalpy equation. If I take total derivative of pressure will be there. So dou p by dou t plus u dou p by dou x. And this is the convective term rho a square dou u by dou x. Okay, we will see the equations. This is 1D, unsteady, inviscid, compressible. So I have rho t plus u dou rho by dou x plus rho dou u by dou x equal to 0. And ut plus u dou u by dou x minus 1 by rho dou p by dou x equal to 0. Next pt plus u dou p by dou x minus rho a square, I think, plus rho a square dou u by dou x. Like this I got. Okay. So if you see here, what are the unknowns? What is the solution vector? The primitive variables to be solved?
Rho P U V.
Rho
UP. Okay. So rho t, ut, pt are there. So rho up. And so this can be written as qt. Okay. So rho t, ut, pt it covers plus a qx equal to 0. It will be something like this. Am I right?
yes, sir.
Yes, sir.
So can you tell me now what is A matrix?
U 0
U,
rho
rho,
0
0. From the first equation, I am taking rho x, ux, px derivatives. Rho x is u, ux is rho, and px is 0. In the second equation,
1 by rho
no, rho x is not there.
0, 0 u
U
minus 1 by rho.
plus 1 by rho. And here,
0
0,
rho a square
rho a square,
u.
u, like this. So if you see this, actually, this is like qx plus mqy equal to 0. It is in this form, right?
Yes, sir.
Yes, sir.
So if I take the eigenvalues of this, I know the behavior of this. So only eigenvalues of A only I have to find out. I am not writing ADX plus BDY. Okay, because I don't have like that. Is it clear? So this is in this form. So I have to find out the eigenvalues of M or A here. So how to find out the eigenvalues? Again, A
A
minus
minus lambda equal.
I equal to 0. Means U minus lambda rho 0, 0, U minus lambda minus 1 by rho 0, rho A square U minus lambda. So if I expand with respect to this column, so only U minus lambda into will be there. So U minus lambda into
U minus lambda whole square
U minus lambda whole square
minus A square plus A square.
plus A square. Hmm. I think I'll have minus A square. Just let me see the equations. I think I have to get minus A square.
Sir, it's plus 1.
Okay, plus 1 by rho w by dx. Sorry. So this is plus 1 by rho w by dx. So this is plus 1 by rho. So here it will
Minus
be
A square.
A square. So if I take this, so U minus lambda into this is like A square minus B square, right? A plus B into A minus B. U minus lambda plus A, U minus lambda minus A is equal to 0. So I will have 3 values for lambda. So this will give me, because U minus
Equal to U.
0, U minus lambda plus A equal to 0, U minus lambda minus A equal to 0. So lambda 1 is equal to U, lambda 2 is equal to 1
U plus
A,
U
lambda
minus
is equal to U minus A. So what type of equations these are?
Hyperbolic.
Hyperbolic.
Hyperbolic. All are real. So hyperbolic. So this is the way we classify the equations. Now is it clear?
yes.
Yes, sir.
Okay. So there are either that way or this way we can do. If there are two derivatives like a qx plus b qy like that, then I have to do T matrix and all. And if I have like this, qt plus a qx equal to 0 or qx plus m qy equal to 0, then I will have the eigenvalues. Okay. So
Sir, there was one more case where
yeah.
the roots were less than the number of equations. So in case like lambda 3
Parabolic, parabolic. If
yes,
I
sir.
have parabolic, if all are real and less than the number of equations, that is parabolic.
So sir, like if lambda 3 is equal to u plus a, in case if it was u plus a, so
And then
can
it
we
will be
consider lambda
parabolic.
3 and
Then it will be
like
parabolic. If both
parabolic,
are
no?
u plus a,
Hmm.
then it will be parabolic.
Okay, sir. Thanks. That is what I wanted to ask.
And the next thing what I am interested in is because normally if you remember diffusion terms are second order terms. So if I have the equation having both first order derivatives, second order derivatives like that. So what should I do? If I have like suppose 2D incompressible viscous flow. Okay, if I have like that, so suppose continuity, I have ux plus by equal to 0. If I take x momentum, so I will have ux and I will take steady. Ux plus v uy is equal to minus 1 by rho dou p by dou x plus mu uxx plus uy. And y momentum u dou v by dou x plus v dou v by dou y. This is non-dimensional form. Otherwise, sometimes you will have dou of u square by dou x, dou of uv by dou y. This is conservation form, right? So both are same. If you are writing this way or that way, it depends on that. So here, this is convenient to solve it. So minus 1 by rho dou v by dou y plus mu like this. Okay, now I have these type of equations. I know how to solve when there are all first order equations. So if I have second order equations, I have to convert them into first order equations. Similarly, if you have, suppose, I don't know whether you have solved it or not, Runge-Kutta method, ordinary differential equations when you take, right? So that is for first order equation. But if you want to have second order or third order equations, if it is third order equation, I have to write it as 3 first order equations. If it is second order equation, I have to write 2 first order equations. And how to do it? So here uxx, uyy, vxx, vyy is there. So I will take some additional variables like if I take like vx is equal to a. Okay, something like that. So then vxx will become ax. Am I right?
Yes, sir.
Similarly, suppose vy equal to b I take. So vyy equal to by it will be. And similarly, I will take ux, I will not take because vy is b, ux will be minus b, right? So I need not assume it. So uxx will become minus bx. I will have to assume another thing like uy equal to c. Then uyy equal to cy. Am I clear about this?
Yes,
I
sir.
introduce 3 more variables into this so that I can rewrite the equation. This equation, how can I write it is u into ux is minus b. So minus ub plus v into ui. Ui is c.
C.
So vc is equal to minus 1 by rho px plus mu into uxx is
Ax
minus b,
plus Cy.
minus bx and plus cy like this. And the next equation u vx. So u vx is a plus v vy is b is equal to minus 1 by rho py plus mu into vxx. Vxx is ax. Vyy is by like this. So instead of this equation, I will have this equation. Instead of this equation, I will have this equation. But now I have unknowns like u, v, p already are there. Now I have introduced a, b, c. Okay, so I have to generate 3 equations. Okay, this is first equation, this is second equation, third equation. I should have 3 equations more. So I can take either these equations, right? These also like equations only. But for better thing, I generate some equations like I will write like ux y minus uy x equal to 0. And vx y minus vy x equal to 0. Like this, I can generate equations. Okay, ux of y means ux is minus b. Okay, so minus by minus uy is c. So minus cx equal to 0. I can take it as plus. So this is one equation. And another vxy. Vxy is ay. Vyx minus vyx. Vy is b minus bx equal to 0. So like this, I can generate equation. So I can take this as 1 and this as 2, this as 3, or this. Okay. I will take one of these 3 equations. I have to take one as one equation. You can take anything. Okay, in the textbook, actually, he has taken this, but you can take any other equation also. If you take this as 1, and this as 2, and this as 3, this as 4, this as 5, this as 6. Okay, you can take in any order because one workload example is there. I have taken in that particular order. So I can take like this. And once I take like this, I have to write them in AQX plus BQY is equal to 0 like this, or 0 or C or something. And now Q matrix. So I will have UVP ABC. Okay, again in the textbook it is taken like UVABCP like this. But again you can take in any order. So only thing is when I write A matrix, I have to write the coefficients of UX, VX, AXP, BX, CX, PX in the A, and B, Y derivatives I have to write. Okay, so this is the way I have to go about. I will show you that. Okay, so because I have to write all these things. Okay, these are the equations. Instead of dimensional form, he has taken non-dimensional form. When you take non-dimensional form, 1 by rho will be absorbed in the P, right? So it will become dou P by dou X. That nu will become 1 by Reynolds number. Okay, so these are the non-dimensional form of the momentum equation. So you have an exercise problem where you have nu given here instead of 1 by Re. And here minus 1 by rho dou P by dou X will be given. Okay, whatever be the way, the method is same. And if I take the textbook like this. Okay, this is the problem. Okay, this is taken. And Vx is A, Vy is B, Uy is C. So dou E by dou X, because Ux plus Vy equal to 0, as I told, Ux is minus Vy, which is minus B. And this is the way it is the dou V by dou X dou Y, dou square V by dou X dou Y. And if I take this, this is the another equation. This is one equation. So like this, all the 6 equations, these are the 6 equations he has chosen. So as I told, it can be dou U by dou Y or dou V by dou X or dou V by dou Y, anything you can choose, right? So like that, 6 equations are chosen. Now in this, I have to write A matrix and B matrix. So A QX plus B QY it is given. So A matrix. A matrix, suppose if I ask here, in this you tell me what are the coefficients. There are no x derivatives at all, right? So all first row of A matrix are zeros only. Am I clear?
Yes, sir.
In the second equation, I have only Ux is there. That is the second element will be 1, all others are 0. You can see here, sorry. How it is taken, Q matrix. Q matrix is taken as U, V, A, B, C, P. Okay, rho is not there. Rho will not be there, sorry. U, V, P, A, B, C. I don't know. Okay, I have not written it. So U, V, A, B, C, P. In the first, there is no x derivative. In the second one, Ux is there. So 1 will be there, all other zeros. In the third line, in the third equation, what x derivative is there? Bx is there. B is which term? Fourth term. So fourth term will be 1 and zeros. And the next equation, this equation, Cx is there. That is, C is 1, 2, 3, 4, 5, fifth element. So fifth element will be 1. And when you take these equations, okay, here I have minus Bx and minus Px. This is minus 1 by rho, 1 by Re Bx minus Px. So in the place of B, I will get minus 1 by Re. In the place of P, I will get 1. So here UVAB. Okay, so here minus 1 by Re. In the place of P, I will get minus 1. Am I clear about what is that I am telling?
Yes, sir.
Yes, sir.
Okay, so like that, I write the A matrix and B matrix. So once I get that, so T matrix I will get. Instead of dx dy, he is writing nx and y. No, it doesn't matter. Because dx dy, I thought it will be easier for you because dy by dx slope I have to get. Okay, like that I have written. So this is the T matrix I will get. I have to get the determinant of this. Because there are many zeros, it is easier to get the determinant. Suppose if I take according to this row, so I will get ny. And this row and this column can be eliminated. Now I have to get this. Again, ny is there. Okay, so ny whole square into determinant of this 4 by 4 matrix. So in this 4 by 4 matrix, you can take this row. So ny into determinant of this and nx into determinant of the other 3 rows, 3 columns I had to get. So that is the way if you get 1 by re ny square into nx square plus ny square whole square. This one you will get. Okay, so if you see this, what will be dy by dx?
Plus or minus I.
Plus or minus I. So these are elliptic equations. So the system is classified as elliptic. So that is the way we have to go about. Is everything clear?
Yes, sir.
Yeah. And so here in the exercise, so this is like assignment for you, right? The first assignment. It will be up to, these are very easy, right? All straightforward. And so here it is asking classify the following second order partial differential equations. So you have to tell whether it is elliptic, parabolic or hyperbolic, because second order ABC you have to find out and get it. And then here like determine the values of x and y to make the following partial differential equations elliptic, parabolic and hyperbolic. So here it is like m Mach number like that. Okay, so you have x and y are there. So for what values of x and y, this becomes elliptic, parabolic and hyperbolic. You have to find out. And then it is asked that x momentum equation, incompressible flow with zero pressure gradient is given by this. Assume mu be constant. Reformulate the equation into conservative form. How you do it? This is non-conservation form, right? So how do you convert this into conservation form? Anybody? I have to use continuity equation to convert this into conservation form. How do I use it? Do you remember? Here I have ux plus vuy. Okay, and my continuity equation is ux plus vy equal to 0. So what should I do? Can anybody? So we have taken the momentum equation, energy equation, we have taken the non-conservation form and converted into conservative form, isn't it? I have to
added the continuity equations.
Yeah, multiply by u and add here, right? So ux plus uvy. Okay, if you add these two, 2u ux plus uvy plus vuy, and this is dou of u square by dou x, 2u dou u by dou x, right? Plus this is dou by dou y of uv. Am I clear about this?
So
Yes.
So this is conservative form. Okay, I have to use the continuity equation, add it because this is 0 only. I add it here so that I am going to get conservative form. So we have done this, right? For momentum equation, energy equation on the right side, when I take rho du by dt, right, which is rho of dou u by dou t plus u dou u by dou x plus v dou u by dou y plus w dou u by dou z, like this. So what I have done to convert it, I have multiplied it by u dou rho by dou t plus u dou rho by dou x. This is continuity equation v dou rho by dou y, like that. So by adding that, I get dou of rho u by dou t plus dou by dou x of rho u plus dou by dou y of rho uv plus dou by dou z of rho uw equal to 0. So in that I get, which is dou of rho v by dou t plus del dot rho v. Like this I get. Okay. So this is conservative form. This is the way we have to go about. And okay, the other governing equations, some are given. You have to classify them. So the 12 problems, right? So the first 12 problems, you can do it very fast. No, all are easy, right? So this you have to take it as assignment. I will send you in the Google Classroom thing. So you submit in the Google Classroom. Is it okay?
Yes, sir.
And okay, here some things I would like to add before completing this chapter. Yeah, there are some things I have to define: consistency, stability, and convergence. Okay, later we are going to be in detail, right? There is one chapter on this, on consistency and stability. Okay, so a finite difference approximation of a partial differential equation is consistent if the finite difference equation approaches the partial differential equation as grid size approaches 0. Okay, so I have partial differential equation and finite difference equation. In the finite difference equation, I will have the grid size like delta x, delta t, those things. So if the delta x, delta t, those things, if they tend to 0, it has to become the original partial differential equation. Then we call this as consistent. Okay, so that is consistency. And stability. So whenever we write a program, right, and solve in a computer, I told you there will be what is called as round of error. So at a point, there is some round of error is introduced. And all the other points are calculated using this point. So this error gets propagated. And when the error is propagated, if it is growing or decreasing, that is important. If it is growing, it is unstable. If it is becoming less, that is stable. A numerical scheme is said to be stable if any error introduced in the finite difference equation does not grow with the solution of the finite difference equation. Then we call it as stable. So I have to check whenever I use a scheme whether the particular scheme is stable or not. Okay, so that is another thing. And then convergence. Okay, you know that any problem should be convergent. As I do the iterations, right, the error should be decreased, and finally it should be converged. That is the final solution. Okay, so that is this. A finite difference scheme is convergent if the solution of the finite difference equation approaches the partial differential equation as the grid size approaches 0. Okay, so that is this. And later there is what is called as Lax's equivalence theorem. If a particular well-posed problem, a linear initial value problem, if it is to be convergent, it must be stable and consistent. If a scheme is stable and consistent, it is automatically convergent. Okay, so this is proved by Lax. But only thing is, he has proved only for linear initial value problems, but not for all. But people take it as a little bit general, but it's not yet proved. Okay, so that is Lax's. If a scheme, you have to check stability and consistency. If it is consistent and stable, then you can take it granted that it is convergent. Okay, and the conservative property or divergent form of the equation. When all conservative form of the equations can be written in divergent form, like del dot rho v, del dot rho v be like that. And so this can be written, this is in conservation form. If I expand it, it will become non-conservation form. Okay. And first order PDEs occur only occasionally in engineering problems. Almost all first order equations have real characteristics, because first order equations normally we get when you are considering convection terms. Diffusion terms are second order derivatives. Do you remember? Always the terms that give us problem are convective terms. Diffusive terms they are linear, because Laplacian del square v, right? Dou square u by dou x square, dou square u by, that is Laplacian. Okay, and that is linear. There is no problem. But on the left hand side, I have u dou u by dou x, v dou u by dou y, like that. Okay, they are the nonlinear terms that only always give us problem. And so when I have first order derivatives of convective derivatives, I am going to get real characteristics and I am going to have hyperbolic nature. But if I have diffusion terms, it is elliptic in nature, and there is no problem with that. And equations with more than two independent variables may not fit neatly into the classification of partial differential equations described in this chapter. However, the concepts of elliptic, parabolic, and hyperbolic can be extended to such PDEs. Okay, we are not showing a complete Navier-Stokes equation. If I take, I cannot show it whether it is elliptic, parabolic, or hyperbolic. But the concepts, if you take whatever we have used till now, you can understand how it behaves. And not all problems expressed are purely elliptic, parabolic, or hyperbolic. We have seen that if some are real and some are imaginary, it will have both natures. On many occasions, a problem expressed as a mixture of elliptic and parabolic equations or mixture of elliptic and hyperbolic equations. Like that. Okay, so this completes the first chapter. And any questions? So if there are no questions, I will stop here. Next class, we will start the next chapter. This is the first chapter of Hoffman, right? This is there in all the books, right? But here it is a better way it is represented. And Hoffman book is mainly comfortable for the students because there are some worked out examples, some exercise problems and all. If you see any other CFD books, you will not have the problem solved, because unless you solve the problems, you cannot be confident. Many times concept will be clear, but unless we do something and solve problems, you will not get confidence. So these Hoffman books are convenient for that mainly. Okay, next class we will see how to convert the partial differential equations into finite difference equations or algebraic equations. That we will do in the next class. Okay, if there are no questions, we will go for the story. Okay, it is about Stephen Hawking. I think all are very, very familiar, and many people love him also. And we will see because he is one of the great inspiring personality. And Hawking's first challenge in life was one of his family's concern, as his father's firm went bankrupt early on in Stephen's life. Okay, and you can see most of these great scientists and achievers, their childhood is very, very poor and very challenging, right? Many times what people think is, so my family is poor, or we don't have facilities, we don't have comforts and all, how can I achieve this or that? And some people have everything given to them, and that's why they could do this. So it is not that. Only the people who face more challenges will achieve great things. Okay, that you can see from the history. So his family was unable to afford without scholarships to receive the education they felt his mind deserved. However, Stephen saw positives in this and saw staying in his current school with his closest friends playing board games and such as a greater benefit to him anyways on his path to attend Oxford University at 17. And Stephen Hawking had a lonely life early on in Oxford, but as his time went on, he began to settle in and slack on his studies. Upon his graduation, Stephen and his family were shocked to discover that he had been diagnosed with motor neurons disease at the age of 21 and was given 2 or 5 years to live on average. Okay, so that is the situation. You can see how the mental condition will be. See, this sent Stephen into a deep depression that he felt he would never escape from, with all his work and studies feeling pointless due to his inevitable death feeling just around the corner at every turn. Okay, so once you know that you are going to die in 2 or 3 years, and what is that you will do, right? You will lose all interest in everything, and there is no point in achieving or trying for something, right? That's what people feel, and they get depressed. He also was in that. As his disease worsened and he needed more care, Steve had his first major health scare in 1985. He had contracted pneumonia, which led the doctors to have little other choices than to put him in a drug induced coma. Just imagine the condition. It was his wife. Have you seen that movie?
Which movie, sir?
What is that movie name?
When you see the Constitution.
Yeah, a fantastic movie. You just watch it. It was his wife who was left with the decision whether or not to end or continue the life support. However, instead, she made the decision to send Stephen to Cambridge to have a tracheotomy surgery. This was the surgery that completely cut off Stephen's
ఈ
ability.
స్టేట్ లో కనుక ఆ గవర్నమెంట్
Theory of everything, sir. Movie name.
Yeah, theory of everything.
వాళ్ళకి స్పెసిఫిక్ ఫంక్షన్స్
And Stephen would continue to live with motor neurons disease for over 50 years, despite the short lifespan that many with his disease are given, and would go on further his career exponentially. Despite being diagnosed with this deadly and terrifying disease and being given 2 years to live, Stephen Hawking went on to have his written thesis approved by his university, and alongside this obtained his PhD in applied mathematics and theoretical physics in 1966. He has also written an essay titled Singularities and the Geometry of Space-Time, which went on to win one of the most prestigious awards, the Adams Prize in Science. Hawking's successes were only beginning there. However, as in 1974, he made the then controversial discovery that black holes emit radiation. This would eventually be accepted as a scientific breakthrough because black hole is everything absorbing, right? So nobody could imagine that it emits radiation. So breakthrough rather than controversial, and the radiation that was discovered would be named after Hawking as Hawking radiation. And Stephen Hawking made a full recovery from his tracheotomy too, and not too long after sold over 10 million copies of his book, A Brief History of Time. It is also a master book. So if you didn't go through it, please go through it. Fantastic book by Stephen Hawking. This was a record-breaking bestseller as it appeared on the Sunday Times bestsellers list for a whopping 237 weeks in total. He defied the odds so much and stated that this has not prevented me from leading a full and active life, in reference to the impact he was allowing or not allowing his disease to have on his progress as a person. He also would go on to co-author children's books alongside his daughter. And Hawking would be a figurehead for the warning of public figure on the catastrophe that awaits humanity with climate change unless drastic changes are made to our reliance and overindulgence industry-wise. So he also cautioned about this. Despite many of these recommended changes being ignored, still to this day, Hawking can never say he did not warn us when it comes to the everlasting impacts climate change will have on our planet. Lastly, Hawking was a figurehead for the possibilities at hand for those with disabilities. For many, there is an ignorance that people with severe disabilities have a lower ceiling than those without disabilities, and Stephen proved that theory completely wrong by achieving what seemed like the impossible with his illness. Hawking has inspired both non-disabled and disabled people alike to realize that the ceiling of people with life-altering disabilities is as high as they want it to be. So it depends on what you want to be. It doesn't depend on the abilities, right? Anybody can go to any level. So what is that lessons we can learn? First, do not be panic in the face of doom. Okay, you can read it. And not to let your obstacles define. So your obstacles should not define you. And positive thinking is the key. Okay, so in conclusion, Stephen Hawking was a man who was dealt a terrifying hand and that somehow defied the odds and made the most of his situation to the extreme. He broke barriers for disability and climate change and was a best-selling author as well as a renowned scientist who had made groundbreaking discoveries. This attitude and mindset was something we would all learn from Stephen Hawking. So he says, however difficult life may seem, there is always something you can do and succeed at. It matters that you don't just give up. And he says, I am not afraid of death, but I am in no hurry to die. I'm in no hurry to die. Okay, great personality and inspiring. Thank you. Thank you very much. Okay, this is another one. Okay, thank you. See you then. See you tomorrow.
Thank you, sir.
Parliament
Thank you,
only
sir.
against
Thank you, sir.
Thank you.